So your basic communication between an application and a processing module is a very simple. You basically define the command string. So this is something where for a plugin, in order to use the plugin properly, you'll have to read the documentation for the processing module on what commands that it understands. But if you want to build one, again, huge flexibility here because you can design your own command set and make them available simply as strings. And then to actually start the module processing or to stop it, you have simple activate and deactivate calls. And I think we have, so this is actually sample code for the processing piece for a Jack client. So the main piece of code that you're going to, this is the thing that's actually going to be receiving your data and where you're actually going to be doing your main processing. So just time to walk here. This is a trivial example where you're literally just copying the data coming in from a port or two ports and then copying it back out to generate so it's basically a pass-through sample. It's nice, in the SDK there's actually samples, there's about 5 or 6 samples and they show you all the different, pretty compact examples of how to build all the different kinds of things here. So to actually create something as a plugin and to kind of notify the system that you've got a plugin, wow, that pointer is incredibly small. So the plugin is going to run as a service. You're going to identify it with an intent filter down here where you have your action, your intent filter that recognizes an action that's Samsung, Android, SDK, professional audio. Sorry, you have to type so much, .plugin.pick. So that means it's going to be responding. So part of the framework here, what's really nice is that actually, once you register things this way, and all plugins would need to register this way, is that now the system can allow you to iterate through all available plugins that anyone has written and figure out which ones are available. So you'll actually see a sample in the SDK samples where it shows it iterating through all of the possible plugins on the system. And I don't know if we're going to start the demo at that point, but when you bring up the demo, you can see where it's initializing and it's actually going through and finding all the plugins.
Is there a private versus public plugin?
No, it's pretty much all public. So I believe that's correct, right? Yeah. So making it simple with the manifest. So we're actually running a little ahead of time, so I think we can show the demo and then we actually have a nice video to show as well that we can do.
Okay, I prepared some demo and I will show you our initial project. I think it's a good example to start our SDK, I think. Okay, switch. Okay. Okay. You could see some virtual instrument. Okay. First one is MIDI keyboard, and second one is sound processing module. Third one is mixer, and the speaker is a system out. And actually, 3 applications is loaded. And interesting is first one is MIDI keyboard. Is I said that type 2. Type 2 is UI only, right? And then the second is type 3. Type 3 is processing module only. It's and it's just use plugin. And third one is mixer. Okay. Actually, this one is connecting to the sound module. The blue wire is MIDI cable, and black wire is a sound PCM cable. So that I will start testing. Okay, I'm not playing it. Oh, sorry, mistake. Okay, you could heard some sound. Okay. Actually, it's MIDI keyboard doesn't have own sound processing module, and the MIDI data go through the MIDI cable and then go to the sound module. Sound module, it doesn't have any UI, and just okay, MIDI data is come and processing some sound, and the sound is come out to the audio modules. Okay, okay, I will explain these kind of things next. It's just the UI. And okay. Okay. This is a type 1 application. It has UI for manipulating, processing sound module, and it has an invisible sound module, sound processing module. And it's kind of volume control or panning and equalization and something. Okay. And okay, I will explain background application. Do you have any question at the moment? Okay.
I do.
We have
Two questions. First is best case latency, and the second is USB audio support.
Yeah, okay. Good question. Latency is at the moment is usually Android device have big latency because there's some audio current Android audio subsystem has prepared much buffers. I already explained that our framework is working independently and just share ASA driver. Our framework is directly connected to the ASA driver. So in ASA latency is decided buffer size. Our SDK could choose low and mid and high latency select. At the moment, it's just the setting. First setting is minimum is 256 frames. It will be around 5 milliseconds, and
That's at 48K?
but
At 48K?
exactly right. At the moment, it's 48K is default. Some hardware support 48K and then 44.1 kilohertz also support, but in the mobile side, 48K is more normal. Yeah, that's why we set default. Okay, and second question is
USB audio.
USB audio. Okay, right. I said at the moment, as MIDI I/O is disabled, I said that. So that usually in computer, personal computer is also MIDI drive used to connect MIDI device. So we are disabled, and at the moment, and then we are using bulk USB, and then the bulk USB is sending command. We translate to the MIDI signal, and then we are also support in our SDK.
But not audio input by USB and audio output by USB?
Okay, so at the moment, this audio input is disabled. Some troubles we have, so that still we are continuously working on, and at the moment it's just disabled. It will be enabled in next year. Next version will be enabled.
So it's only the built-in microphone that's the input, or the built-in ECM?
But
There's no USB input, so where's the audio coming from?
USB audio at the moment doesn't support.
Hmm.
Yeah. Audio input doesn't support.
So what inputs does it support? That's what they're asking.
At the moment, it's okay. Okay, I'm misunderstanding. USB MIDI and USB audio, right? If you make USB audio, okay, USB audio client, if you make, then you could connect. It's same as the MIDI, but just default audio input is not a support at the moment. If you make a USB audio client, then you could connect. You already experienced.
But also the MIDI is supported.
Yeah, USB MIDI is going to support, and then the module is included our SDK. Yeah.
Is this available only for certain Android versions or all the way to Gingerbread?
Okay. I'm also very interested is how it's working on the Google side, and at the moment our framework just support start in the H project. It's not H project. It's Note 3, and then Note 3 started, and then currently 10.1 also support, and then we will extend.
So only for these devices I can use this?
What?
Only for these two devices I can use this?
Yeah, at the moment we will extend.
Yeah, it's this support for a lot of the mobile SDK stuff is going to be moved out to older devices going forward at some point. But
Sorry, which two devices?
the Node 3 and the 10.1 2014 edition tablet.
Can I follow up on the latency? So if I understood correctly, the answer to this gentleman was 5 milliseconds latency. That's currently
That's the size of a buffer, but how
Yeah,
many
it's-
buffers?
10 milliseconds, 2 buffers.
Well, how many buffers is also using though? Two or three? Between the input and the
Yeah,
output?
two. Actually, you could decide also, but at the moment it's used 2 buffers.
The earlier slide said 2.
Okay. Well, that was a generic SDKs.
so the inherent latency is 10 milliseconds end to end.
Okay.
More.
So at the moment it's mobile device. Okay, it depends on use case. And mobile device is first input. In this case is touch sensor, right? Touch sensor is recognized, and then some gesture, something is, and then that message sent to UI. That is at the moment is big, making some big latency. We reduced audio side, but actually at the moment is touch latency, which doesn't much reduced. It around at the moment is around 65 milliseconds. It's very worse, I think. We are keep working on, but as you know, Samsung Note is support hovering and something, and then now it's very complicated than before. Touch sensor, that is spend a lot of time, and then total time is okay. Touch latency is 60 milliseconds. Our framework is around 20 milliseconds, and then 30 milliseconds, then 90%.
So, but if you don't need touch input,
Yeah.
just
Yeah,
the
if
audio.
you're just interested in what the audio.
Audio.
latency.
Just audio is latency. Okay. If audio input use, then at the moment it doesn't support. That's why I doesn't tell you. I was experiment in a just dependent on buffer size and how much buffer use, and then front end audio delay. Front end audio delay is very pure. It's not quite much. Some device around 10 milliseconds, something is just 1 point, so very pure.
Did you want to show some of the, yeah.
Okay. We prepare some other. I also want to introduce our application. I hope to what we have done and then what we are currently. I think this is also a nice example. It's kind of CAD instrument, and then I think we are keeping developing and application side. Okay, and
We have another question.
I hear a lot of clipping.
it's just okay. It's just I think saturated in. I just reduced the volume then. Yeah.
Yeah, that's just the sound system that we're
Yeah.
going through, I think, so.
Because it could be that many instruments together just bring everything into.
Yeah.
We can come up and listen to the tablet afterwards, and we'll tweak the sound. You can hear it's very pure. So.
Sorry if you already covered this, but I think I didn't get it. Is the analog input of the device labeled for audio processing? I mean, can I plug a guitar there and?
Right. Actually, I really love guitar effect or guitar gear. That is the reason why I started. Actually, at the moment it's not disabled. I said that we will provide audio input. Looks like a speaker. Well, actually, okay, it's a strategy, but at the moment this input doesn't support. We will add
Okay,
input
in the
client.
future. Exactly. Thank you.
Another question. So if I understood this correctly, you completely bypass the Android audio stuff, right?
Mm-hmm.
What does that mean for the codecs, for example? I mean, there's, Android has native codecs. Are they used, or are they? Do you need to duplicate them, or what's the situation there?
Okay, it's usually it's some native code also you could use if you make a client. It depends on if you make internal. If you use internal codec and then make just a client something like a Type 3 application then you could use. It's not all.
You can use the Android codecs, the
Yeah.
native,
Yeah,
native
exactly.
codecs.
In our example, application used MP3 encoder, we are using the Android native codecs.
Same as AAC or
Yeah, exactly. So at the moment, I'm introduced the whole application. We didn't using nothing special API, just a general Google API, and I was as professional as well. And also, even if native codec or something, you could use, and then just put the processing of it. And it's possible.
you also said that applications need to be a little adapted to use your framework here.
Yeah, it's
Does that mean that applications that were not built for it are not going to run, or they just run in the old Android stuff, or how does an application decide which to use?
Okay. Okay. So, easiest way, I think it's not quite special. Just we download our SDK and then use enable the device if you're using, and then just pure class if you
So
use
basically,
it.
the framework is completely independent. So you could use the Android native audio if you want, and it'll run fine. It'll run like standard Android, or you can set up the service for our framework and do it that way. So they're basically completely independent. So.
But your app needs to have both if it wants to be usable on many devices, right?
Yeah. So that's the joys of building something that's better than what's out there. So.
What's the plan if Google addresses
we're
this finally?
almost out of time here, so.
I mean, Google should really do what you have been doing, right? In terms of latency.
That'd be
Yeah,
nice.
it's our framework is not just low latency solutions. I said Jack is very many advantage, kind of synchronization, MIDI channel support, MIDI port support, and then switching and user level switching.
Well, he's talking about, whether Google planned to implement something like this. I mean, we don't know, so we're not waiting.
Okay. If Google is making a nice low latency driver, we will making input client. We will use that input, and then making input client. Then we will be working code. I think that is our strategy.
And typically what Google solves their kind of base platform issues, so they might do something that lowers latency or whatever, but they may not provide like all the interconnect features and things like that, so.
Exactly.
But I don't speak for Google, so. Okay, I think we're actually out of time, but we'll be around for a little bit, so. Sorry?
Is the code for this demo available on the site?
The code for the main demo that we just showed, I think is, you said you were getting published, but isn't out yet, right?
Some sample is already published. So
Good.
yeah.
Having some templates and samples
This
available.
one and this one.
Yeah, there's template code for samples in the SDK for all the kinds of variations of things to implement. That's really easy to read.
This demo would make fantastic to go to.
Yeah.
Okay. My latency is half there.
James to Yeah, of course. Yeah, thank you very much. And do you have this?
I don't know if you brought it. So if you get in touch with me.
All right, thank you.
데모하다가 간단하게 고등학교 질문하니까
You know what's right.